Hey everyone, this is Dr. Walker, and this is video 501, Vector Addition using Unit Vectors. We have already talked about vector addition, see video 15, but in this video we are going to do it a different way using unit vectors, and it turns out to be easier actually. So let's take a look at adding vectors in 2 dimensions using the unit vectors. Let's say that we are given vectors a and b. They have an x and a y component. So this is vector a here with its x component and its y component. And then we have vector b over here with its x component and its y component. And we know that to add vectors, we have to add the components separately. So we know that to get Rx, for instance, we're going to have to add ax plus bx. And to get ry, we're going to have to add ay plus by. So what we're going to get to find r is we're going to have rx in the x direction, right? Rx I hat plus ry j hat. And then to get Rx, we just do Ax plus Bx. That's going to be followed by the I hat to specify the X direction. And then we're going to have Ay plus By followed by J hat to specify the Y direction. So if you have 2 or more vectors, all you do to find that resultant vectors is you add up the x component of each vector and then follow it by I hat. You add the y component of each vector and follow it by j hat. What about if you are trying to find the magnitude of r hat, right? Well, we know that r hat is the hypotenuse of the triangle made by Rx and Ry. So just like before, we're going to use the Pythagorean theorem. Magnitude R is the square root of Rx squared plus Ry squared, where once again, Rx is given by Ax plus Bx, and Ry is given by Ay plus By. What if we want to find the direction of vector r? Well, we know that if we specify an angle, let's say angle theta over here for vector r here, we know that the tangent of it is going to be the opposite ry over the adjacent rx, right? We know that tangent of theta is ry over rx. So therefore, we know that to specify theta, we take the inverse tan of ry over rx. And that will give us the direction theta relative to the x-axis. Now what about if we want to add vectors in 3 dimensions? We're going to do the same thing. The only difference is that our vectors now have a z component specified here with k hat. But we're still going to add all of the components separately. So add up all the x's and follow it by I hat, right? Add up all the y's and follow it by j hat, and add up all the z's and follow it by k hat. So that's what you're going to get here. You're going to have the x components and followed by I hat, the y components followed by j hat, and the z components followed by k hat. To find the magnitude of the vector, you're going to use the Pythagorean theorem again. But this time, because it's 3 dimensions, you have rx squared plus ry squared plus rz squared and take the square root of that. Now to specify the direction of your vector r in 3 dimensions, you're going to have to specify relative to which axis. So for instance, theta x here would be the theta this would be theta x, right, relative to the x-axis. And so to find theta x, you would do the inverse cosine of Rx over R. And if you wanted to specify the direction relative to the y and the z-axis, then you would use the corresponding equations here. So this is how we add vectors in 2 or 3 dimensions, and we will do an example in the guided example video that follows.